All right, section 2.6 is on implicit differentiation. So, we know how to differentiate functions of the form, well, like this. You have x times sine of x. We would take the derivative there using the product rule. Something like this, we would use the chain rule because what's inside the radical is not just x. We have a composition of functions. We would use our composition rule or chain rule. But if we have equations like this, well, we don't know yet how to find the derivative. So to do that, we use what's called implicit differentiation. The big idea is that y has to be able to be written explicitly as a function of x. So something like this, right? And all the functions we've seen before. This is y explicitly as a function of x. But if we take this example right here, where we have x squared plus y squared equals 25, it's hard to get y by itself. What we could do is we could say y squared is 25 minus x squared, and if we take the square root, we have 1/2 of this function. Y of x is 25 minus x squared. Another half of the function is, square root. Another half is going to be the opposite there. So it's hard to get y just by itself. So in this equation, y is implied to be a function of x. But it's not explicit, because for it to be explicit, looks like this. Y of x equals blah, 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 where the only things over here are x's. So, the idea will be to differentiate with respect to x normally, with all the pieces that are already written in terms of x, and then to treat y as a function in terms of x and use the chain rule there. So this example says, find the derivative for the equation x squared plus y squared is 25, and the equation of the line tangent to this circle at 3, 4. Okay, so we're going to start with x squared plus y squared is 25. We take the derivative with respect to x on both sides. So we have the derivative of x squared plus y squared equals the derivative of 25. So on the right, we know this is going to be 0. And on the left, let's go very carefully here. The derivative of this is just going to be 2x. And now we just need to talk about how to take this derivative. So since we treat y as a function of x, we will need to use the chain rule to differentiate y squared. That means this y squared is going to be a function of x, and we're going to think about that being squared. And I want the derivative of all of that. So the derivative of something squared is 2 times that thing. And since this thing on the inside is not just x, I have to multiply by the derivative of the inside by the chain rule. This is using the chain rule. So we have 2y times y prime. Another way to write that is 2y times dy dx. So here we're going to get 2x plus 2y times y prime. 2x plus 2y times y prime. I'm going to go through this fast because we're going to have more examples coming. Now we need to get dy dx by itself. So we just do some algebra, right? We put this guy over here, we divide by 2y, and we're done. So we get this. So then finding the tangent line at 3/4, well, that's the same. We know this is the equation of the tangent line. It's going to be y equals m times x minus a plus f of a. This point that they gave us has these coordinates, right? Just an x and y. So we can plug in 3 and 4. All we're missing is the derivative. So m, when x equals 3 and y equals 4, is going to be negative 3 divided by 4 using this, right? The derivative is the slope of the tangent line. So we plug that into here and we are done. Okay, so we'll have a couple more videos on the next